All right, hello again. This is another problem on your chapter 4 take-home thing. Um, oh, well, it's like your problem. I made up a new problem like this, like number 4. So here's a function, y equals 5 over 2x squared plus 7, very similar to your function. And the question is, find the x values where the tangent line has the greatest slope and the least slope. Now, one thing that helps is a quick picture of this function. Maybe you could use your graphing calculator, but real quick, it looks like this. And so when does it have the greatest slope? I can sort of tell that the tangent line has the greatest slope when it's the steepest. I think it's the steepest somewhere in here. When the tangent line is the steepest, which, by the way, is the inflection point. When is it the least slope? Well, it's, by the way, the slope is positive, now it's the greatest slope, now it's still positive, and then the slope is 0. Can it get lower than 0? Well, yeah, there's a negative slope, So I think the steepest negative slope is right here. So I think those two inflection points is what I'm looking for. And how do I find inflection points? I need the second derivative equal to 0. So this is going to take a little work. But first I want to explain what it was. The greatest slope or the least slope turns out to be those inflection points. Well, here we go. To do the first derivative, you don't really need a quotient rule. You can move this up and rewrite it as 5 times 2x squared plus 7 to the negative 1. Do a little power rule, chain rule here. The derivative is negative 5, 2x squared plus 7 to the negative 2. The chain rule multiplies by the derivative of the inside, which is a 4x. If I clean that up just a little bit, it looks like the numerator is a negative 20x over 2x squared plus 7 squared. So that's y prime. I think I did okay there. But I need y double prime to find the inflection point. So I need the second derivative, and here we go. I think now I will do a quotient rule. All right, derivative of the top, negative 20, times the bottom. Minus, write down the top. And please take the derivative of the bottom, which would be 2 times 2x squared plus 7 to the first times the derivative inside, which is a 4x, all over the bottom squared. The bottom denominator squared, that's already squared. When you square it, it's to the 4th. Wow. All right, I want to set this equal to 0. When you set this equal to 0 to find the inflection points, you set the numerator equal to 0, basically, but we can simplify it a little bit first. I can cancel a 2x squared plus 7. You might think of factoring it out and then canceling it. If you don't mind, I'm just going to cancel a 2x squared plus 7. It cancels into there, leaves me 3 of these, but I can only cancel it if I can also cancel it in this term, so I cancel 1 of these. So my numerator that I'm setting equal to 0 has just become this, negative 20 times this to the first. I think I'll distribute that. No, I won't. I think hang on, negative 20 times 2x squared plus 7. And this is canceled. I do have this denominator, but again, I'm setting it equal to 0. I'm only concerned with the numerator. What is this? A positive 160x squared? I think that's right. 40 times 4. Yeah. All right, well, I do want to distribute that. That is negative 40x squared minus 140 plus 160x squared. I'm setting this equal to 0. Again, I ignored the denominator, just setting the numerator equal to 0. What is this? I'm going to move the 140 over here. I'm going to combine like terms. That's 120x squared. I'm going to divide by 120. X squared becomes 14 twelfths, or 7 sixths. I'll be darned. 140 over 120 reduces to 7 sixths. So can you tell me what x is? X squared is 7 sixths. I guess that leads me to my answer. X is plus or minus the square root of 7 sixths. Those are my inflection points. I don't need to prove they're inflection points. Those are the answers. Those are the places where we have the greatest slope and the least slope. Wow, that was fun. I love those answers. Roughly, 7/6 is a 1. The square root of 1 is roughly a 1, but it's actually a little more than 1. So these answers are just a little bit more than 1 and negative 1. All right, thank you very much. I thought it was obvious which one was the greatest slope and the least slope, but if you notice, I referred to this picture again. I think this x value is the negative x value there. That's the one with the greatest slope of the tangent line. And I think this positive one, x value, is the one with the least slope of the tangent line. So perhaps I should refer to that. This is the x value with the greatest slope on this function, and this is the x value with the least slope for this function. Thank you very much.